Hello, class. I hope you're doing extremely well. This week's article is about portable drug analysis. So this is an interesting societal, you know, problem because, well, right now, if there are some drugs suspected, there are various tests. One of them, for instance, looks for methyl salicylate. Well, if it reacts with something like cocaine, it'll form a chemical like methyl salicylate, which is oil of wintergreen. So the police officer can just try and smell the for wintergreen. Or you can do colorimetric tests, like okay, so this color could mean this. So and this is done throughout many things. So for instance. Like the emergency response team, that's like the CSI folks for a crime scene. They'll go and they'll spray various things like phenolphthalein or hydrogen peroxide to look for things like blood, and or something like some visual like an alternate light source ALS, looking for various fluids, and then they collect those and send those to the crime lab. Problems with drugs. Quite frequently, individuals, if there's a positive test where something might be a drug, the person's arrested. And in this case, this article talks about an individual that was put in jail for 6 weeks. So you can see here, Juan Carlos Toscano Guzman spent almost 6 weeks in jail, and he was innocent. So, and well, this is a problem, right? I mean, it's of course very, very unfortunate for Juan, but I mean, Juan is not alone in this. So what is a solution? A potential solution that they're looking at is portable spectrometers. So you can use these tiny portable spectrometers, and they have, I mean, they're not as good as, say, a benchtop in a laboratory, but you can see they're small, and they can give much more accurate results. And so this will greatly reduce the amount of people being falsely accused and unfortunately having to spend time in prison when they are clearly innocent. So this is interesting, and I like some of the stuff here. And so if talking about myself, I've gotten in trouble a few times because if I'm in the airport and they start scanning me for things like, like, oh, we've decided to look at you, and so they let me down and they put a machine. I'm like, oh, I was like, what is that machine and what are you looking for? And they're like, don't ask questions. You're not allowed to ask questions. And I'll even say things like, oh, I was on the farm the other week. You might find some nitrates, and they're like, sir, do not ask questions. Don't talk to us, kind of thing. So I've learned, of course, not to talk to the TSA agents other than, sort of the generalized, just hello, how are you kind of thing. So it's I'm sure that they're doing this in the TSA. Of course they're doing spectrometers. So they're clearly spectrometers, but they apparently are not telling us what kind of spectrometer they're using. So, but it's interesting. This is interesting, and I think this is nice. This is something where we are using technology to help people's. This is helping law enforcement, and it's also preventing the innocent people from being put in prison. And it also presents other problems. And you can see here, for instance, like fentanyl. Fentanyl is a very potent, dangerous drug, and it's very similar to acetaminophen, at least as far as when they're scanning for it. I mean, they are different molecules. I don't take acetaminophen very frequently, but a typical dose is 500 milligrams. You can see 2 milligrams can be a fatal dose. I mean, obviously they're very different molecules. So, well, I hope you find it interesting, and I hope that you personally are very well. If you find yourself that you are not doing as well, please feel free to reach out to me, and I, of course, will do whatever I can to help you. So take care, hang in there. I know we're getting close to the end, so it's a tough time, but I'm going to stop there. So aloha for now.